One of the takeaways from our discussion of sampling distributions was that when we sample from a population, one sample could look entirely different from another sample in terms of descriptive statistics, and both samples could look entirely different from the population at large. Here we see a population with mean mu and standard deviation sigma. Sample 1 of size N1 with mean Y1 bar and standard deviation S1 could look very different from sample 2, whose statistics are Y2 bar and S2, just based on how the sample was randomly chosen. And the same could be true for any other sample that we might collect. As such, we shouldn't put much faith in, for example, a sample mean as an estimator for the mean of an entire population. When we use a sample mean to estimate a population, we're boiling all the information we have about the sample, its mean, its dispersion or standard deviation, the fact that it may not be representative of the population at all, into a lone number, or just one point. We refer to this one point as a point estimate. We use point estimates all the time in daily conversation. How long does it take you to get to work? On average, 20 minutes. You're turning all of the observations you've had of driving from one place to another, with traffic and without, into a single point. And you're using that single point as a sample statistic to estimate a population parameter. There's a better way to estimate population parameters using a tool from inferential statistics called a confidence interval. We'll be discussing and applying confidence intervals in this unit.